Would you be able to provide me with a list of 10 steps for each of those steps? Could you also provide me with a list of 10 steps for each of those till you're using your specific muscles? This implies a lot of questions, don't you think? First of all, LLMs will be able to provide some level of extraction for some of those questions, but they won't be able to replicate the millisecond by millisecond muscle control required to get out of a chair correct. However, if they have been trained to generate such plans, they may be able to provide you with a plan down to a level of abstraction that can be expressed in words. They will be unable to prepare for circumstances they have never faced before. In essence, they are required to repeat the pattern they were trained on. A recent broadcast about Tesla's most current upgrade, full self-driving 12.3, attracted a lot of attention because to its amazing capabilities. Its midterm planning, especially in the 20 to 30 second range, is a significant cause for concern, nevertheless. A recent discussion between Lex Fridman and Jan LeCun presented a possible solution, suggesting that hope may be on the horizon. They investigated the idea of VGA as a potential solution to this problem. Let's analyze this interview to see what we can discover. However, before you do anything else, remember to click the like and subscribe boxes. Let's get going now. The foundation of VGA's operations is hierarchical planning, which divides difficult jobs into smaller, more doable segments. For example, one would set more general goals like getting to the airport and catching a flight rather than meticulously organizing a journey from New York to Paris. These would then be further divided into smaller objectives, such as navigating security and calling a cab. The successful use of hierarchical planning in AI systems is still difficult, despite its potential. Without all the components, it's like trying to solve a jigsaw. Although Tesla's full self-driving 12.3 is a technological achievement, its planning skills should be strengthened. Might VGA be the answer? An expert recently discussed the difficulties of arranging multi-step projects, comparing them to commonplace situations such as planning a trip to Whistler, British Columbia, or traveling from New York to Paris. They underlined how difficult it is to anticipate every detail, particularly when dealing with unforeseen circumstances like flight delays or strange surroundings when you arrive. Moving on to the topic of autonomous driving, the expert described how Tesla's full self-driving technology addresses both top-down and micro-level planning, providing real-time knowledge of surrounding impediments and route advice through the use of Google Maps. However, they identified a crucial area where FSD currently fails in the 20 to 30 second planning range. According to Jan LeCun, the problem is the computational cost of predicting every millisecond of movement, which is doable for industrial robots, but unworkable for cars driven by humans. Human-driven jobs like driving necessitate adaptive real-time decision-making, whereas industrial robots can perform repeated tasks with perfect preparation. They also looked at how other businesses, like as NVIDIA and Tesla, are addressing the problem of hierarchical planning. They underlined the necessity of planning at several levels of abstraction in order to enable optimal task navigation by vehicles or humanoid robots. They did point out a major obstacle, though, in bridging the gap between minute real-time actions and high-level planning. The possibility of using language models to help with work planning was mentioned in passing, and their capacity to create plans using training data was acknowledged. They did, however, draw attention to the limitations of LLMs in creating plans for activities involving complex physical actions or unexpected environments, highlighting the value of experiential learning. In her discussion on collaborative embedded predictive architecture, the speaker raised the possibility that it could improve hierarchical planning. In their words, they were excited about embodied AI and how it could lead to more intelligent agents. Although a wide range of subjects were discussed, such as embodied AI and high-bandwidth learning, the main emphasis was on the need for sophisticated planning architectures like GEA to achieve efficient hierarchical planning in autonomous systems. In any case, the concept here is about what big language models can do. However, Yan feels that a critical component is missing from the transformer architecture and diffusion models. Since language is an abstraction of reality rather than reality itself, he contends that these structures are by their very nature disembodied. Additionally, they need a lot of data to train, which is a problem for Tesla right now as it tries to properly train its bots. Yan argues that because joint embedding predictive designs are hierarchical rather than generative, they provide a solution to this issue. He presents VIPPA, a novel architecture created by Meta with the goal of building extremely intelligent machines that can learn just as effectively as people. VIPPA may learn notions about the physical world in a similar way to how a baby learns by watching its parents, because it has been pre-trained on video data. VIPPA works with masked input videos and doesn't need to be fine-tuned like generative models do. Without direct supervision, it makes predictions about what will occur in the masked-out area after drilling a hole in the video block. Yan highlights the significance of this strategy by pointing out that it keeps the model from depending on the less successful autoregressive training method. How do you feel about this new design for AI? Will it make people more optimistic about Tesla? This is also the opinion of many industry professionals. And who else is as optimistic about Tesla? Our pals from Seeking Alpha. There is more to Tesla's remarkable success than merely watching from the sidelines. With the most recent information on Tesla, stock price targets, innovation, and all things Elon Musk, Seeking Alpha is the one-stop shop for Tesla bulls and those with an eye for finding the next big thing in the stock market. One of the top online sources for pro-Tesla news is Seeking Alpha. Get down to the facts and avoid the lamestream media's anti-Tesla rhetoric. For a unique discount, click the link in the description. The difference between generative AI and what is being shown with this VJEA model is what is truly taking place here. You're basically asking the model to fill in the missing pixels when you use generative AI. For instance, you might ask the AI to recreate the original image if you had an octagonal stop sign and chopped away a section of it. This method, however, is computationally costly and does not reflect how people organically engage with the environment. Instead of perceiving every detail, humans construct an abstract picture of their environment. You might mentally map out where items are in your office, for example, without having to remember every pixel. Similar to this, VGEA predicts what will happen in masked-out areas of a video by operating in a latent space, which is a condensed representation of reality. Rather than creating pixel-perfect reproductions, the goal is to comprehend the context. The strength of VGEA is its predictive architecture, which enables it to ignore extraneous details and concentrate on figuring out the main idea of a scene. This method results in more effective training and a more profound comprehension of the universe. VGEA makes a more grounded contribution to the advancement of machine intelligence by forecasting what will happen in videos. With its emphasis on comprehension rather than duplication, this release represents a major advancement in AI's capacity to grasp the world. VIPPA aims for a deeper comprehension of the underlying concepts, similar to how humans naturally see and explain their surroundings, whereas generative models strive for pixel-perfect precision. Regenerating intricate scenes pixel by pixel is a difficult task in machine learning. Rather of replicating every detail, models such as VIPPA concentrate on comprehending the core of a scene. This method enables more thorough comprehension of item interactions in dynamic situations, as well as more effective training. An important step in the development of machine intelligence has been taken with the distribution of VIPPA under a Creative Commons non-commercial license for researchers. It permits additional investigation and growth in the comprehension of the universe and the effective completion of difficult activities, like driving to the airport or negotiating shifting traffic circumstances. Similar to how GEA analyzes abstract representations of images rather than actual pixels, VIPPA's non-generative method learns by predicting missing portions of a video in an abstract representation space. Because of its adaptability, it can eliminate material that isn't useful, increasing training efficiency by up to 6 times. Furthermore, it can adapt to a variety of jobs with little supervision because it has been fully pre-trained using unlabeled data.